Okay, so for this problem, I want to find the reactions that supports A and B. So I'm going to start by doing statics on it, right? So I'll have A reaction, a B reaction, and then a moment here at A. And when I sum the forces in the y direction, I'm going to get A plus B minus P, which is 5 kilonewtons. So minus 5 equals, and let me do 5,000, put that in newtons, equals 0. Okay, then I'll sum the moments about A. I want to make sure I include my moment A, the reaction moment at A, and then I have L times B, where L is 8, so 8B, and then minus 12 times 5,000 equals 0. So here are two equations, okay, but three unknowns. I have A, B, and the reaction at A, the couple moment at A, excuse me. So what I need to do here is I need to kind of do superposition and get another equation that I've got. So what I'm going to do is I'm going to actually break this up into two beams. First beam will be 5,000 acting at the end like that. And then the second beam will actually be B acting right there. And again, essentially that's a beam with 8-meter beam with a force at the end of it. The rest of it's going to just keep going up. And what I know in this process is that the deflection at B has to be 0 because it can't move at B. I can have deflection any other place, but not at B. Okay? So what I have here then is I have the deflection due to the 5,000, okay? And this is going to be, I need to use this equation on that guy, okay? Because it's occurring at 8 meters, but it's a 12-meter beam, okay? So, and this one's going to be going, this is going to cause a deflection downward, so it'll be negative 5,000 times 8 squared, okay, divided by 6EI times 3 times L, where L is 12, that's the total length of the beam, minus X, which is where it's located at, which is 8, right? That's the where the deflection is 0. To that, I'm going to add the deflection of B. And again, this is essentially just like a 8-meter beam at the end point. So it's going to be that max deflection of P, and this is up, so I have upward. So instead of P, I've got B. Instead of L, I have 8 cubed, and then 3 EI. So I have the deflection of a deflection at 8 meters of a 12-meter beam at the end, and then a 8-meter beam at its end. Okay, so adding those two together, they have to add up to 0. From that, I can actually solve for B, and I find B equals 8,750 newtons. Now that I have B, I can easily go find A, which is going to be negative, so that means I have it drawn in the wrong direction, no big deal. Okay, and then I have the moment, which apparently I also have drawn in the wrong direction because I get negative 10,000 Newton meter. Okay. So again, you just break this up into two pieces, knowing that the deflection at point B has to be 0. I have two beams. I find the deflection of each at B, add them together, set them to 0 to get that third equation that helps me find the reaction at B. Then from that, I can just use statics to determine the other two.